So I'd just like to say a very big thank you to all that have joined us this evening. We've got a number of the council on, and we've got a number of the amateurs. Thank you for your time this evening. I am sure it is going to be a very interesting presentation. Nico, it's not often we have our council lead on this. Would you like to say anything, Nico?
Yeah, sorry, you caught me off guard there. No, always, as I said, always a pleasure. And I do find this once a month sort of a get together. I just wish more guys on the national level will join in. I love the topics, and let's put it this way: it's my half hour or hour sort of leisure time within the hobby. And thank you for the Center guys for really making this one of their top priorities every month. So, Chris, yeah, I only saw you joining there, and with Guy as well, the youngsters, Guy looking after the youngsters who will definitely be participating in flying their little cube once again with Christo and the team in Secunda later this month. And as I said, we definitely must make a plan to get more attention and roll this out on a national level. This is really something worthwhile on Thursday night, last Thursday of the month. So once again, thank you, and let me disappear. Christy, you just carry on. We can't wait.
Thank you for all the introductions, Nico and Keith. And I must also say thank you to the council for the support of this initiative. Without support like that, we will struggle to keep it going. And yeah, luckily we are going to launch the 11th formal balloon, and for the 11th year this initiative. So I'm very glad to be also part of the SIRL. 2008 I got my license, so I'm very excited. As I said, once you have that piece of paper, the world is your oyster. You can do whatever you want to do, just legally. Okay, I want to talk about the BACAR tonight, and the BACAR stands for, or is a shorten for balloon carrying amateur radio. So the primary purpose of the BACAR is to have some sort of a amateur radio payload on it, and there is several of them, and we'll see that later. Just about the structure of this presentation, if you have to listen to me for an hour, I think it will be boring. So I've invited the core team members to also make a small short presentation on the parts that they are zooming in onto. So Willie, ZS6, VBT, WBT, Whiskey Bravo Tango is here. So he will go after me, and he will give us a little bit more detail about the initiative that we have with the schools that participate. Most of the schools is from areas that you know, they're very disadvantaged in those areas. So we try to just get them then going and see how they can develop and how we can spur some interests in science and technology and engineering, mathematics a little bit. But we have a challenge with regards to teachers in this country, but I think the people is there to learn a lot. And that is what is making me quite excited about this project, is that some of the participants in our balloon flights in 2014 and 2015 is currently engineers. So they have studied. And I think also, if I'm not mistaken, Guy's son will also finish sometime with his engineering degree, if you have not done it already. But yeah, so the people, we try to spur interest in this thing. So I just want to say about this slide is, this is where we stay and this is where we work. In the background, most of us used to work there. Some of them are on pension already. I am looking forward, in less than 56 months, I will also be on pension. I will be joining Gert, who will be presenting as well tonight. So Gert will present for us a little bit on the chase teams, which is also a section of BACAR that is also very exciting, because it's a whole other environment. It's different. It's fast. It's very interesting. Gert will tell stories about our balloon flights, the first one and the last one. I think it's two highlights for me, the first one and the last one last year. That is, but let him speak about that. And then we also, I don't know if Core have joined us. 06 Charlie Romeo. He will talk a little bit about the base station that he runs for us. So Core looks at all the incoming telemetry, and then he organizes the chase teams, and he also developed for us our shuttle that controls our flight. So that is the three people that will present tonight. I forgot to mention Gert's call sign is 06 Golf Charlie. So most of you have probably have him in your logbooks. I just want to. Okay, I have screen sharing, so I need to go to my screen to advance it. It's the next slide showing there on your side. Not yet. Okay, that's the next slide. So what is our vision? I've touched on it a little bit. It's about learn while having fun. And I think that is the key of our program is we need to have fun. If we don't have fun, why do we do it? You can't always learn. All work and no play makes Jack a dull boy is the only thing I can remember from my English classes in the Free State. Yeah, so we need to have fun. So we try to build in a fun factor, and you would see if you participate in this thing that you will generate a lot of excitement in your team whilst launching the balloon, chasing the balloon, finding it back, and analyzing your data. Then, of course, gets the science project into the near space. Now, the science projects can be either something electronic, it can be something that just mechanical. There is just a huge amount of areas that the people can excel in. There's people that can design your payload, what do you call it, the structure, and just to develop them in terms of 3D printing. Maybe they have a CNC machine and they want to machine something out of that, and then use that as the cube for the payload. There's just, you can also use wood, you can use anything just to make. So we try to just stimulate, and we try to use the scientific method of deciding what you want to test, deciding what you should see as your outcome, put it as an hypothesis, then build your payload, test your payload, send it up in the balloon, get it back, analyze your data, and then relate back to your hypothesis, because it's very important that we get to install that in our children's heads today, because today they just see somebody driving a fancy car and then they want a fancy car as well. But these people has come a long way, and the world has come a long way. And it has come this way because there's a proper scientific method where you can properly evaluate the science that you want to test. There's not somebody there, someplace under a tree that tells you the earth is flat, you know, or the earth is round. This is proven. So we try to get that proven part into it. The theory, that is also very important. I sit in a class, they read a handbook, they see stuff in a handbook, somebody writes stuff on the blackboard. They say if you go higher in the air, the air gets thinner, there's no pressure. Yeah, so what? But if they built a CubeSat with a little pressure sensor in it, they can also see that we can compare it to the height, either via the GPS height or something. So then they can practically see what it says. They can practically see in the electronics class what happens if you put a resistor in the what is a stroom bar, the circuit. Yes. And then, of course, teamwork. Teamwork is for us very important. And we don't supervise and guide. The team does it themselves. I think it's one of our core principles, and it is part of our mission as well. You will see here that teams without a formal leader is more successful than other. So we don't want to tell them what to do. If we get to a school and there's people there that we are coaching in this thing, we want them to figure out what to do. We don't tell them, go and do this, go and do that. We guide them in the theory and we give them the outcome that we want to see. And then in between themselves, they will figure out how to do it. So our commitment is our pride. So while we use our passion for our hobby, I think that is something that we need to work on. The passion for our hobby. Yes, there's people doing SOTAs. There's people doing parks on the air. There is people doing there's LEO satellites, the low Earth orbiting satellites. There's people working on the what's it, Q1 100 QC or something 100, very far away. It is just so diverse, this hobby, that you can do anything that you want to do, and that is where the passion comes from. So some of us likes to do HF, some of us likes to do APRS, and some of us likes fox hunting, some of us likes to just sit there and work, see how good our communication can be on the 2 meters repeater. But that is what the hobby is about. There is space for everybody. Nothing is better than the other one. And we let others learn. So that is where it comes from, is by coaching, we let others learn. And the last thing is there, we turn unsuccessful and successful and never give up. I think after our first launch, there was a lot of excitement in the group and we wanted to launch the next one. So we did launch the next one and we lost all our payloads. It was a letdown. You can imagine the letdown because we have trained for 8 weeks. We spent hours with people in the schools to build their payloads, which Willie will talk about later. And then we lose it. So we decided, okay, that was probably a fluke. The area that we launched there in Vryburg area is not conducive to this kind of sports that we are trying to do. So we built another one. And we also flipping lost that one. So that was bad. I told the guys, this is the last launch, so we are not going to go on with this. And then they convinced me there's just one more, and we're sitting at number 11 coming up. So yeah, that is also something that we also need to understand, is we should not give up early. Maybe some things takes longer. Maybe we want some extra bandwidth somewhere and we need to convince Castle or something. So we never give up, but we also do it with passion. Yeah, this is just some of the information that we usually give out. And if you can make a screen print of this is usually what happens. We have camping available at the Eiffel Sailing Club. So if you want to arrive on Friday, it is very reasonably priced, and you can contact Gert with information about that. Saturday, it's very early. There's a reason for that. I'll tell you later about that. And then on Sunday, the people depart. So usually Saturday night, it's a lekker braai that we do. We have the chase teams there. If you want to participate, you can contact Gert, especially after tonight's presentation. I think you would enjoy being part of the chase team. Since there is a fox in this thing, I think, guys, we need to explore that and just get in contact with Gert. Then we have our non-electronic payloads. As I said earlier, you can have any scientific type of payload on it, just no living animals. Please, I have friends in the SPCA and they are serious. Even if you send a cockroach to space, they will not like it. So contact Willie. Other payloads in general, other payloads, if you, we will, from next week onwards, we will have about 2 meetings every week, just to confirm all the payloads that's going up and all the weights and stuff like that. But I'll talk about that a little bit later. And then Cor, our hoofman, the master, he is our contact person with SRL and all the media people, so that if we get in trouble, we push him ahead. Now, this is what the balloon looks like the day of the launch. It's a 2,000 gram balloon. It gets filled with approximately 14,000 liters of hydrogen. And then you can see the people that is busy with it. They wear latex gloves. You're not allowed to touch the balloon. The oil on your skin will create a soft spot on the balloon surface, and then it will either burst or tear or something while it is going up, and we don't want that. We want this thing to fly the whole flight, and preferably either burst or we will release it. And then, yeah, this is just some of the participants also on the screen. Photos and what we are aiming for to see. Just some interesting photos is we always fly something that can give us a little bit of a perspective of where we are. Incidentally, this was not that high. This is less than 10 kilometers high, and you can see a veld fire in the bottom left. You can see a veld fire there. That is that was on that occurring, and then here on the bottom right-hand side, you can see Chrissy's Mere area, the place where the Vaal River sprung. And you can see the main lake there at Chrissy's Mere. Okay, and this is what we all aim for, is the blackness of space, and to get a proper photograph of that. The bottom right one is, of course, one of the best ones that we have. And then here it just shows you there's the atmosphere around Earth, and then the blackness of space. And this is what we aim for. If we reach there, we know we have a successful flight. And this is what we want, because Kailum Prope Spatium is the space near us. So we would really like to, that is our motto, and we want to be there, and that is what we want to explore, and we want to give the people chances to test their equipment in near space conditions, so when they do develop payloads for later on other purposes, then at least it goes into near space. There is just a few photographs of our payloads. You can see the structures there of the cubes. I think this middle one on top, that was an HF EC2V transmitter that we flew one day, one of the flights, I think in 2016, that didn't work so well. And here you can also see the CubeSat structure on the left-hand side. And our parachute, now we have interesting tales of the parachutes as well. Once the parachute did not open, but we did find all our payloads back, and that is why we keep on putting the polystyrene around them. Except for trying to keep out the cold, it also dampens the force when it hits the ground at approximately 70 kilometers an hour. That usually doesn't happen. We usually go down about 20 km an hour. But in terms of our payloads consist mostly of some sort of power supply, microcomputer of whatever sort you want to, the sensors, the experiments, the non-scientific ones, and then some sort of RF packages. Not all of them have RF packages in, and they can be slow scan TV. There is definitely APRS, and whatever you want to put on it in terms of RF. LoRa is also very nice to have. Uses very little power. A very interesting mode as well. And then the specs. Yeah, we try not to exceed 500 grams per payload. We try to keep the payloads at 500 grams because we want to give more people a chance to put the payload on the balloon. And the balloon, the heavier it is, the longer it takes, or it doesn't go that high. So the lighter it is, the higher we can reach. The CubeSat size as well. Yeah, we try to, we can't give you unlimited size because then we don't think, we just put in, and there's no innovation in the whole experiment. So we are limiting it to 10 centimeters by 10. It's more or less the CubeSat size. So we try to give the guys an idea how to put all your experiments in that that volume. And then, yeah, with the insulation, we should not exceed the 14 by 14. because the winds blow, and when the stuff falls down as well, the smaller packages, they will tend to go faster, and then the bigger ones, and then they overtake each other on the way down. So we try to keep it as organized as possible. So if everything is the same size, we can mostly get a proper train coming back again. But yeah, it's very interesting on the videos. Just in terms of the connecting of the different payloads in the train, I think you have seen the photograph of all the payloads hanging down below the balloon. We do not want to put stress on the structure of your payload. So you do not fasten anything on your payload structure, and we do not hang anything on your payload structure. If your payload is one of those ones that structure is a little bit flimsy and it breaks, we will lose half the train underneath your payload and your payload. So what we do is we put strings right through the payload. I tried to make a drawing here. On the left-hand side, you see the little ring. This is just for quick attachment to the other payloads. It goes through the payload and comes out at the bottom again. I tried to make a drawing. It's not that clear. And here you can see the strings going through the payload, coming out at the bottom. And this is the payload on the right-hand side with the lid. You can see that the strings is going through there. If we do it this way, the most that your payload will experience in terms of stresses is maybe if in a swinging motion or something, but the main forces will be on the strings. So that helps us to put all the payloads, and we do not have to worry that one payload is going to break and we lose half of them. Yeah, that's also part of that is part of our payloads, how we construct them. There's a few knots that we use. We try to use the same knot so that it doesn't loosen in halfway in flight. That's also why we have 4 strings going through the payload. In here you can see in the middle you can see cameras. On top you can see the spot tracker, and then all the electronics on the inside. On the left hand side, that was the SSTV payload, and what we did that year was at a certain height we released it. It fell away from the blue and white one, fell away from the red one, and then yeah, it started also when it pulled the trigger as it fell away from the red one, and then it started transmitting. So yeah, that is just a highlight and easy quick way of attaching these things and construction. Yeah, we have received a lot of different construction methods and all of that. Just as long as it works for you and it fits into the payload specs, this is fine. Then we fly it. This is just in the payload train, yeah, because we have a lot of RF packages on it. We need to do some sort of band planning as well, and vertical separation of the payloads in terms of their frequencies. So we try to keep it apart, so that there's not too much interference. But this year we are, our motto is RF Unlimited. So if you want to fly something like your Fox, we also need to test the robustness of our technologies. So in terms of the modes that we are using, this is a very good way of experimenting with that. And I just wanted to show you on the screen as well that in the shuttle on top, which controls the whole flight, if Cor has joined, he will tell us a little bit more about that. But in there we have a tracker that transmit a GPS that transmit GPS strings on RTTY, that we can see the telemetry, battery voltages, temperatures, as well as the GPS output of the waypoints. On RTTY, very interesting, very nice to receive, very reliable. We also have on that same payload, we have a cell phone tracker. That usually stopped working around about 6 kilometers up, because then there's no cell phone reception, but when it comes back again, it starts working again. We have still cameras, spy and video and all of that. And then we have APRS. Definitely, we have APRS on every flight. The normal 2 meters APRS, because there's a lot of digipeaters in the country and a lot of eye gates in the country that can pick it up for us. Then we have the GigaCube last year. They had a transponder on it. And then we had telemetry, the LoRa telemetry on it. Very interesting as well. There's a satellite tracker, the Spot satellite tracker from Garmin, because we need to find our payloads back. Very important that we get them back, because with the learning experience and the bad experiences that we had. AfriCube is the satellite transponder being developed by SRL team, SI OMSAT. So they were on there as well. Then we had the LoRaWAN tracker on it as well, because we need to find our payloads back. And then, yeah, we had very interesting stuff on this payload, where we had the Mestastic, we had LoRa on it, we had the HF SSTV on it. There's a camera on it, and then BACAR itself is a Mode C transponder, or Mode S transponder that we had to buy, and we need to say thank you to the guys in the Val Driehoek, the Val Triangle, and Sasolburg club, who sponsored that equipment. It was a hell of a lot of money, but it creates comfort with the CAA and ATNS and CAMU and all those people that needs to approve our flight. We don't want to fly and hit somebody in some sort of airspace and then nobody knows about it. By informing all the authorities and keeping them happy, we can fly our balloons peacefully and constantly next year as well. But this ADSB beacon makes them happy. So we have about six trackers on the whole payload train, because we need our stuff back, and we get different results with it. So, but it works. All of them works fine. Then just the day of the launch, you can see this is an aerial video of the Trichardt Model Flyers Club. And the red spot is where we fill the balloon. Yeah, just the necessary people needs to be there, because it's a delicate situation. It is hydrogen, and all of us have seen the Hindenburg video. Yeah, and people don't want to get close to there. I usually ask for brave men to come and help me to fill it. There's a few guys in our club that is now very proficient in filling the balloon. And the rest of us hang around in the back here. You will see just behind this, in this green area, there's some afdakkies there where we put our payloads. The emergency services, there's a place for them, because we are a gathering. The municipality needs to send, say, emergency people there and to watch over us and to help us when something fails or something doesn't work out for us. But yeah, this is just the zones. And children just doesn't go, they don't need to go there. They can watch from the side. And we launched the balloon somewhere in this triangle. Yeah, and the children need to keep away, because it's very bad to see your balloon flying up. Some child is standing on a piece of rope, and then your balloon leaves and the payload stays on the ground, because they are also excited. It is the most exciting experience, where they don't always look where they stand. So. But they need to be there to experience it. And then usually we have a whole program for the day set out. We need to do everything, check out everything, and make sure. This year I need to phone the CIA about every 15 minutes. But that will be incorporated in this program for the launch day. And Keith, I have your contact number now, so you will get an invite to our meetings, and then we will go through this beforehand, so that on the day we are there, we sort of know at this time we need to do this time we need to do that. Usually this deviates a little bit by an hour or less. Depends on the weather conditions and how, if everybody arrives. At that time of the year, unfortunately, there's some fog on the roads and it can be misty in the morning. So people drive slowly from the east or the west. In terms of our flight prediction, this was a prediction that we have done. Let me just see if there's a date and time. Yeah, this is last year's flight. Yeah, lekker flight this. Gert will tell you about this flight and the prediction of this thing and the landing spot. But yeah, it was very accurate. It was very accurate. This year, our balloon predictions is going in here, this way, going here, and then landing right here in the middle of the factory. So yeah, I'm stressing that the winds must change in terms of the flight prediction. In my discussions with the CAA, they have some approach point around about here where the cursor is. I don't know if you can see it, but it's just south of Secunda. There is an approach point from the east, Durban, Port Elizabeth, all that areas where they will join the traffic in the pattern for Oliver Tambo. So they don't want anything to go to the west of any of our balloons going to the west of that point. So yeah, if our balloon predictions keep on going that way, we will have to postpone until the winds take it to the eastern side. I trust it will happen in the next week. We had our first rain, so we should start seeing winds going in the easterly direction. Yeah, this is the last slide I have. This is where we started. This whole experience of us started in 2012. I think Chris and the East Rand people launched a balloon there in Klerksdorp. I drove from Bloemfontein. I was studying, writing exams. And the Saturday I went and I watched what they were doing there. I came back and tell stories, of course. And then, yeah, we were in it. As you can see, first flight was only 12 kilometers high. Very nice flight. We have some very nice photos that you will see later on in the presentations. And then we keep on going up, getting more teams joining us, sometimes more, sometimes less. You will see 2020 is not there. It was COVID. And then we need to start up again. You can see our payloads, people getting more efficient in the payloads. We can send 10 payloads now to 31 kilometers up. So that is what we want to do, is we want to get better every year, see what we do. And then, of course, we need to get more people to participate in this. It is quite expensive. The hydrogen that we use is about 11, well, it was 11,000 rands 2 years ago. It's probably about 14,000 rands now just for the hydrogen, and it's gone. You lose it, it's gone. It's 5 grand for the balloon alone. That's also gone. You can't reuse that. Every time that we launch the balloon, it is costly. We got some sponsorships previously, but yeah, the things is well, luckily up to now it works out for us that we can fly the balloon every year. The other thing that I need to say is that even the balloons, the payloads themselves, the cost of that we don't want to calculate, because it's hours that you spend with people to develop their payloads and to put it in there. And there's no price for that, because it is our passion. You don't ask rand and cents for that. But this is what we have achieved so far. I think this is very nice to do. And the more people that can be there on the day, the better. It is part of our hobby that is quite exciting. Thank you. Thank you, Keith, for the opportunity as well. And if there's quick questions, I can take a few. We have spent quite a lot of time, and I still need Gert and Philly to at least present. Thank you, guys.
Thank you very much, Christo. Very, very interesting, hitting 31 kilometers above the Earth's surface. And I've certainly learned a few little things on what you were saying. The smaller packages fall faster than the big packages and overtake one another. I didn't think about that, and why you've got the 4 strings and not connecting to everything. Okay, let's take a few questions. Anybody want to ask some questions before we carry on with the second half of the presentation? Please unmute and ask your question, or raise your hand, or put it in the chat. Okay, I'm not seeing any questions, Christo, so I think we should continue.
Okay, I think that Willie, you can share and tell us a little bit about the VBT, the balloon sets themselves.
Let me just make Willie a co-host so that he can share. Willie, please go ahead.
Okay, I hope everybody can hear me.
We can. Thanks.
What's happening here now? Here's the one I want to share. That one. I'm not familiar with this tool. Okay, full screen. Okay, is that on your side? I'm only looking at what I'm seeing on the side.
We can see it, Willie.
Okay. Okay, thanks a lot for the opportunity to have a bit of a chat here. I'm on my side of the project. It is actually quite a challenge sometimes to talk to the educators in our country to get participation from schools to take part in this. And yeah, it's sad to say, but we do not have teachers out there sometimes that have passion for the science environment. And it's only when you have success with a group of children that participate, you also would see that is normally when you have a teacher that has passion for what he's doing. Some other guys just think we go as radio amateurs going to do everything. Unfortunately, from their side, they also have to help the children. And if we roll out a plan like this, we also say there must be somebody that's the coach, that's helping the children on this project, because we don't have the time and the money actually also to go to these children all the time. And yeah, you get interesting things. I've worked with some schools, and I had to do help them with mathematics and science in the classes that I presented to them, because they don't have a math and a science teacher, things like that. So some of these schools is really in a bad situation. But yeah, let's start to talk about what we give them to fly. Kirsten mentioned there, and I don't have that in my presentation. Since last year, actually, we didn't have much time to spend to get children involved. And then I thought, well, what else can we do? And we came up with ideas, sending something up in a little pillar boxy. We pack it for them in a package, and then we send that up. And I went to one of the private schools around here and said, guys, this is what we're going to do. Take part in it. Now, most of the children wasn't science students, and was interesting the things they sent up. It was from a condom to a ring, all sorts of funny stuff. Things I think that will change color was very interesting. And then afterwards we asked him, now what do you expect us, or what did you expect to happen to the thing that you sent up, and what happened to it? You know, do a bit of work on that, and that's what we want the children to do on this. Okay, just something quickly. I don't know how I end up on this team. My highest qualification is not a degree, it's a grade 2. So some people ask me, and I said I would say grade 2. And yeah, when I was at API, we had a thing called Master Blaster. It was a trophy that was handed to the API that blew up the most components. And I was fortunate enough to get that one four times. And ever since, I haven't stopped blowing up things. I've done it yesterday again. I don't know if Anton is here. I've messed up a radio that I got from him last night. So yeah, that's how things go. I mean, you have to learn somehow. That you learn by messing things up. And then I was a legal radio amateur for quite some time, and then I became a legal radio amateur. Okay, I want to go through this. Quickly, what is high altitude ballooning all about? It's to give the children and the radio amateurs the opportunity, like Christy said there, to fly something on underneath a balloon and to do some experiments and to play around. Now, also the other big thing that I don't mention is to have fun. And we talk a lot of near space. Now, the other thing is, where is near space? If we look at the chart of the atmosphere, the stratosphere starts here just above 10 kilometers and go all the way up to 50 kilometers. And yeah, we look what is flying where. At 10 kilometers, 11 kilometers, maybe 12, you can go at a commercial airplane. And yeah, these days, I don't know where the drones fly. Apparently, they go higher, but normally they fly around about 15 kilometers, and some fighter pilots go up to 15 kilometers. Unfortunately, for these guys above about 20 to 25 kilometers, there's no longer enough air pressure for them to have that stuff flying there. And then that is where our balloon is going. And here at 30 kilometers, we pop a balloon. I'm still waiting for the day that we put up one of those big balloons that goes up all the way to 50 kilometers and above. But yeah, that's another ball game apparently. Right, just underneath the balloon, like Christy have already indicated to you guys, you have your parachute. The thing must come down somehow. And then you have your flight computer sitting there and all the other parcels hanging underneath that. Oops. Okay, the payload, what we give the children or what we want them to build is a little power supply, a microcomputer, and some sensors on it. And yeah, once again, there is just the parameters. We try them to keep to keep the weight down, so this thing can go up. And we try to keep them also in the mindset of a CubeSat these days. There's a lot of Cube satellites up there, and we also try to get them into that space, or into that small little space, to build something in there. I want to see what do we get here. Okay, then we also, you know, when you develop a power supply for this thing, there's quite a few things you must keep in mind. I'm just not going to read everything down there. You guys can do that. But yeah, so one of the most important things that came out from that is that we've learned also is to keep your power supply and the equipment you're going to hook up. Think about what kind of processors and stuff you're going to use there, what sensors you're going to use, and try and keep the voltage the same. The interfacing between 5 volts and 3.3 volts is supposed to be only a resistor. In practice, I've seen a lot of smoke coming out with that as well. So yeah, that's very important. If your power supply generates heat, use that heat to heat up your inside of your payload. A typical power supply would look like something like this. And we also encourage the people to go more for something a little bit more complicated, with current limiting there. When you work with school children, I tell you, I've seen sparks fly, and this is the most robust power supply I've seen for that. That current limiting comes in and protects everything on that. Right, the microcontrollers now. On the microcontrollers, for the children, when they fly, it's actually easier to do the pickaxe because you do the programming in basic language, and it's a very easy microprocessor to learn them. Arduino, some guys prefer Arduino, and I'm also busy to play more with the Arduinos these days. Just for one simple reason, and that is there's so much code on the internet you can copy and paste most of the time, not even knowing what you're doing, but there is a lot of things there. The problem is when you copy and paste stuff. I read that thing the other day on the internet where somebody said copy and paste stuff is easy and let it run, but the moment something goes wrong, and you have to start to do fault finding. You don't know what is going on there. So it helps you also to, you must learn them when they do copy and paste, to actually try to understand what's going on that code. Right, from there we move on. This is just a BACAR processor. You will see that is very closely the same as the Arduino processor with the pinouts on it. The I/O is actually, I would say, more or less exactly the same. With small things here and there that differ. Your programming environment looks like this. It's very user-friendly for children. You can actually simulate it, and you can see what's happening on your processor on the side. The side you write in normal basic language. Right, and then just the types of payloads. The first ones that we built was on, what do they call it, Veraboard or strip board. Now, that picture there on the right-hand side is that's about the size of a quarter of a CubeSat. We have those things on there, and the one that you see there had actually additional interface boards on it. But normally the one that we encourage them to build is your power supply on the bottom, and also the memory card goes on there. Then you go with your CPU on that, and then your interface. And then you also have an external interface board that's sitting here for all the sensors that you put on it for the external side. Now, most of the time you don't have much time to spend with the children to work on this, because they also have to do the school, their homework and stuff. But yeah, if you have more time, we can get very involved in some of the sensors that we put on there. That is your power supply on that previous payload. On this one, that's more or less how the power supply was we're looking at. You have your supply there and the memory board there. This is all the I/O that's put here on the sides, just like the normal satellite or in the inside of a CubeSat. Your CPU board was sitting there with all the pull-up resistors, also on its own board with all the I/O on the side running up and down. And then on top of that, you had your interface board with your internal sensors, some LEDs on there. And yeah, we also had some GPSs on there, things like that. That's why the other one had actually more, the one on the picture have more boards on it. But for the children, we try to stick here, and then if they keep on with this, and next year they can add on to it. That your external board, we have your external temperature sensors, LEDs, programming ports, and things like that on it. And then from there, we decided we must go a little bit there. We find out that there is a more advanced stuff that we can use actually. And we built this one for them with the Yota. And from there on, most of the schools, we tried to get this one to them, but if they want to build the other one, well, that's a lot of soldering. And talking about soldering of school children, that is a challenge. On strip board, I thought it's easy because I'm used to it. With children doing soldering, you in that evenings go home and you unsolder everything and you redo it again. Especially if you're pushed for time to get the payload ready for the flight. But yeah, there's some of the stuff that we put on there. LDR, very nice thing to play around for them to when they learn the programming. But unfortunately, what we've noticed now is it's not worth any information when you go up there. It is most of the time saturated with the light. Right, the newer revision of boards that we use is the BACAR shield board. That is, what's it, AXE41. That's a board that we buy for them to work, that they already have the power supply soldered in there, your processor is on it. And the outside of this looks very similar to Arduino Uno. Actually, the pinout is exactly the same as the Arduino Uno. So yeah, you do the same thing just in Visual Basic, actually in basic language. That's just the I/O on that side. Yeah, that is just a processor. On the interface board, I normally let them put on the 3 LEDs during when we do a class with them, let them write their own little program for a robot turning the lights on and off. That's on your payload that's going up and down. Afterwards, I can take that off and put some other stuff on there that I want to control. Yeah, with a ULN on the other side, also once again with the children to protect the processor from all the weird stuff that I do on the electronics on the side. On board there also you have a variable resistor. That's where you adjust, you fine tune your the voltage that you measure from the battery. And on the other side, you also have your temperature sensors and stuff like that. And also pressure sensors. The one that we use, the printed circuit board that we've made, have a place for a pressure sensor on there that I can use. The analog output. So they can calculate from there actually what that they got out of that pressure sensor and what was the pressure going up and down. And this is the external board with all the interfaces for programming and whatever you want to put on the outside. Okay, that is just to show you more or less where some of the stuff sits. And then we get sometimes get very ambitious. This was a little radio that we built, put up there. It interface actually with that other board to get the data from it. And instead of sending telemetry, we had on this one actually a voice chip. And every now and then it was transmitting the coordinates of the balloon. Yeah, unfortunately, somewhere something went wrong and it got stuck on the last bit of it. Okay, then you adjust your sensors, what to look for on your sensors. You must know the conditions you're going to face up there. And yeah, with the conditions up there, you must know, what's the parameters of your sensors that's going up there. So when you choose your sensors, some of the stuff we must look at. This is just a quick that DS18B20. It's the temperature sensor that we use. It works quite well up to about 50 degrees Celsius, minus 50 degrees. But we've pushed it actually to the limit of minus 55 degrees Celsius. I think it's even colder up there. I don't know, but that's what we did measure. And yeah, there's your pressure sensor. They say it stopped working at minus 40 degrees, but if the inside of your payload is a little bit more insulated, it works actually all the way. Right, and that's just how we measure with the LDR that we put on there. There's a bit of the basic code that goes with it. And yeah, then we also put some motors on it, servo motors to release stuff. When you get your payload back, you download the data. This is how the raw data looks like from that processor. It locks it on the memory chip. So even if that one where we had a drop without a parachute, we could recover the data from it because it was all saved on the memory chip. We just plug it into another processor board and you get the data from it. Yeah, and then that looks quite messed up if you look at the data there. And then you give the table like this that tells you where the different parts of that string is, what does it mean, and you take it apart and you get your information from it. Encourage your children then to take that information and plot it for us on a graph. That was a battery voltage. You can see actually nice what happened with the battery voltage as we're going up and then going very high up, and that was actually at the coldest time of part of it where it dropped down, and then after that where it actually continued. So you can just analyze your battery. On the other side, we have the temperatures. If you look at your internal temperature, the gray line going down there, and your external temperature, it will show you how well that your insulation work that you put around your payload. On this specific one, you can actually see where the balloon went up and it burst here on your external temperature and the sudden increase of it. And then when it was laying on the ground, the internal temperature went just below 0 degrees Celsius in this one. And it took a while actually to heat up again because of the insulation that was so good. That was only polystyrene, by the way. And then your pressure, you can see how the steps coming down here, how the pressure actually came down all the way to where we got to the point where the payload burst. It went all the way down to 0. I think actually before that, stayed below 0, and then it picks up again. And that is what we encourage the children to do. We never see this. Is just something like summary like that, what they saw, what happened, and so on a little block diagram. They ask us how we cover this. Now, Gert is going to cover this in more detail. We use a spot tracker that communicates straight to the satellites, and then you get it on the internet on your cell phone or on a computer. APRS, I'm not going to talk about APRS. I think that everybody knows, and that is where Gert and the chase teams is using that quite a lot. And that is what I have on the payload. The rest of the stuff that's on here is just a lot of photos. That was one of our chase vehicles a few years ago with all the equipment on it. And I'm just going to quickly go through the photos, not wasting more a lot of time. This is going up. And get some interesting stuff like that. We pop the balloon and we come down at the speed. Now this is quite interesting. We once had, instead of this little spaceman of mine that went up in front of the camera, we had a Lego Manny, so one of those little Lego monkeys on there. And we actually have a photo where after the balloon burst, one of the payloads overtook my payload coming down. So Newton's law that says that everything falls at the same speed is not true according to what I've seen here. And it took out the Lego man. So I was very glad that this little man didn't went on that flight. I think you've done about six or so flights. And then you get the drop zone where the payload ended up in the veld. And it looks like that where you pick it up. That one was quite tangled up actually on coming down. There's more information on one of our websites, stratosphere.co.za. If you need more information, there's all the rules and all the different programs that we run there. If you're interested to go and read more. Right, that's all from my side. If there's any questions, I'm open to answer some questions.
Thank you very much, Willie. Anybody got any questions? You can put it in the chat, or you can unmute or raise your hand and go ahead and ask Willie your questions. Okay, I've got a question, Willie. You said it comes down. That's all, that I fully understand. But how, once you see it's on a farmer's property and all the rest, as far as I'm aware, these farmers are quite adept at using shotguns to keep people off their land. Are they amenable to you coming and collecting your balloon from their land?
Yeah, we sometimes have some challenges with that, and I think the challenges get actually worse, especially when you get into company property where once had a balloon that ended up in a mining area.
Right.
Then you have to negotiate with the security guys there to go in there. Before we approach a farm, if there's a farmhouse close where we can see the people or see where the people live, we first go to the farmhouse and ask permission, tell them what it's all about. Sometimes you get guys that have a bit of an attitude that don't want to go in their places, but so far we've been lucky. We also try to warn ahead the farms. If we know more or less where it's going to end up, they all have WhatsApp groups. We try to find out where those WhatsApp groups is, and then we try to warn them, tell them that we are going to be in that facilities. But yeah, I think Gert will tell you more about that. He's most of the time part of the chase team and have all the information on that. I can tell you a lot of the stories that's going on when we're out there.
I just want to add something regarding the farmers in the area. Yeah, we usually send a message out to the area on the farm watch and the boereverenigings where the balloon is approximately going to land. They don't always believe you, but that you can tell where it's going to land. But yeah, we try to inform them, but we also use caution. We were lucky up to now. Thanks.
Thank you very much, Christo. And well, yes, I see that Stuart asked how long does a flight typically last, and Christo's given him the information from 2 to 2.5 hours. Okay, and just a question.
I just want to say the reason, I want to type the reason here is that the winds go quite fast east. And we don't want to go into the Swaziland airspace or into Mozambique. It makes the retrieval of the payloads very difficult. I think the one that went to farthest land on the other side of Amsterdam, very close to the border. So we don't want to go in those places. So we have implemented ways and means of cutting the balloon away before we go into that airspace.
Okay, that is very interesting. I know that we were talking earlier about potentially popping the balloon through some facility, but cutting it away also solves the problem. I'm assuming that's above the parachute so that at least you can parachute down with the payloads. Okay, thank you very much, Willie. Thank you, Christo. Gert, I think you are welcome to take it away.
Good evening. I hope you can hear me.
Coming through loud and clear.
Thank you. I quickly want to get my presentation on. Share screen. Okay, just a confirmation. Do you guys see the screen?
We can see it in presenter view at the moment, Gert, not in spectator view. It's in presenter view. So we got your next slide on screen as well. But it's okay.
Okay. Yeah. A lot of some of the stuff which I got on my slides was also being discussed, and some photos, so that's not a problem. Because chasing from the design and preparations from the start, this whole thing is interweaved with each other, and specifically the chasing part as well. At the stage, we must get the info of all the transmitters and the frequencies. There must be decisions made which transmitters will be tracked. Decided where the home base will be set up and equipment used. I'm not sure, I've missed a part. I had to restart if Cord talked about the home base.
Not yet.
Okay. Just quickly, the home base is a place where we set up a base station. Can be in the field. I'll show you some photos of one in the field. Or at this stage, it is at Cor's house, from where he have a lot more info to get out through to us. Wind speeds, with the newest info, he can tell us how the landing site is changed, etc. So very important that we have a home base, someone which coordinates, and there's time to take all the info and give us some info where the landing will happen. Okay, we must decide on frequencies beforehand, which frequencies to be used in the home base between the change vehicles and also from the change vehicles to the launch site and also from the home base to the launch site. That everybody is updated what is happening with the payload, the balloon that's up in the air. Then beforehand, you must test all your received equipment, transmitters, computers to be used, all the software which is running. For example, APRS, all your software APRS and also all your software one stage from the balloon downwards to the some chase codes. What software. And I must say, everything works quite well. Going up, coming down, the Doppler catches a bit because everything happens too fast in RTTY. We don't get all the data. Then once it's on the ground, RTTY was a very nice digital part to get some info where the payload is. RTTY was quite well when the payload was on the ground. Okay, and with that, as we all know, also at this stage, just to start running landing predictions of the payload. And I've got a picture of some of the predicted landing zones for one of our flights.
Pat, sorry to interrupt. Is it possible to talk closer to the mic? You faded a bit.
Yes, I can do that.
Oh,
Is that
much
a
better.
Is that a bit better? Okay, great.
Thank you.
Pleasure, thanks for helping me. Then also on the chasing car side, we start studying the road maps and farms in the vicinity of the landing zones. That you got an idea how the roads looks like. Is it gravel road? Is it tar? Is it a small two-way spur? Or how does it looks like in that vicinity, and where the farmhouses is? As Willie also mentioned, that you had to go and ask permission before going into the farmers' grounds. And also start gathering weather info on a daily basis for launching and landing sites, because the winds can change suddenly, and that will change everything, specifically for the landing site and yeah, and the speed the payloads will be traveling, the wind direction. As you go up, the wind directions also change. I think I've got a picture a bit later on where you can see where the wind direction changed. I will also show that in a bit more detail then. Okay, then set up for vehicle chasing. Install equipment in vehicle beforehand. Test all to ensure all equipment works. And for instance, a list of equipment I personally install sometimes is you must have GPS with the latest maps if possible. I've got a Wi-Fi router to connect all the computers, notepads, cell phones to the internet running from the car. Which I found a small inverter to take 12 volt up to 220, mainly for the laptops, specifically if the batteries is not in good shape. On our first launch, I did have, we launched from Klerksdorp at that point in time, and it took the payload, was predicted to go to Vrede, but suddenly halfway it changes direction and went up to Annabelle Park and Vereniging, hanging over the fall dam. So suddenly you had to change direction. And after that, the wind take it in another direction, which was not expected over Heidelberg. back to Secunda area. So we changed direction in the car, we're chasing, filling with fuel, and suddenly the computers just crashed. And luckily the shops was open, running into the shop, buy a small inverter, which I'm still using today. Get the computer up and running, try to get some more info of where is the payload traveling so that we can get it. So yeah, that is just one of my experience which we had. So from that stage, I'm using a small inverter. Radios for receiving and tracking payload signals, as discussed beforehand, which you decided, and frequencies. And then thing which I missed, once you're in the chase car, there's no time to play with all kinds of modes, text from the payloads. I like to play with digital modes and slow scan TV and all those kind of stuff. But once you're in the chase vehicle, it's out. You have to concentrate to get that payload back. Then you must install in the vehicle VHF, HF, UHF radios to talk to the base station. You have to talk to other chasing vehicles. And while I'm mentioning other chase vehicles, there's most of the times there is Israel branch help us quite a lot with chasing, and also want to thank them, because without their help, the chasing would have taken a lot longer to get the payloads back. Then another important thing which which happened with me at one stage is once you're out of the, I think we'll come to that, but you must have a driver which concentrate on the road, and the other guy do the handling the computers and chasing and decoding and all that kind of stuff. Then you get to a point on the farm ground which you had to go and feed. Then it is important to have a portable pack of radios to talk back to the chase car when you're in field away from the chase car. So this guy knows what is going on. Cell phone with APRS and GPS software installed to check where you walk. I felt that also in one of my chasings. I was wandering off the field, telling the driver of the chase car, I will be back just now. I think I saw something in the field. Come to that space now, I see something else, and I wander off more and more and more. So what happened is eventually I've got my cell phone APRS on with GPS software installed on the cell phone. And the base station did track me, and he could have seen where the payload was and where I am. And he could have directed me in a more direction of where the payload is. So that went quite well. And also, if you get in trouble, spank your ankle, something happened with you, snake bite, whatever happens to you in the field, they can find you because you are tracked with APRS, cell phone APRS. So it's a bit more of safety for yourself once you're alone there out in the field. Then make sure in your vehicle you pack the raincoat, walking boots to walk in the field, hat, sunburn oil, enough water to drink. At that one stage where I was wandering off into the field looking for the payload, without a hat, without sunburn oil, suddenly I've got this thirst, and I didn't have water with me. So eventually I had to walk back all the way to the chase car, put the hat on, enough water to take some water with me, and went all the way back. to look for the payload. So yeah, I think this is quite important. And once another safety thing, make sure that you know what to do when you're in the field and lightning strikes nearby. That is also important for your safety. Doesn't seem important once you said, oh, we chase a payload, but all these things, or most of them happened with me, and that's why I've put them up with some safety and equipment to put in the chase car. Now we've got some photos and some info, so I will talk through the photos. The first one here is Christo with the school children. It was the one in Vryburg that we've done. Everyone must be briefed by the BACAR leader what is happening in the schedule for the day. But everybody knows, before the chase cars leaves, everybody knows this is a schedule, this is a sequence of stuff which is going to happening. And that is also very important, that everybody be on the same page. All payloads which is needed for tracking must be switched on for testing with the chase cars at the launch site to ensure chase cars received and decode the necessary signals. There is some pictures of the first one on the left-hand side. It was at one stage the layout of my car chasing. There's two laptops and a notepad. This was someone else radio, and here Corey is also setting up and testing before launch. It is necessary because if you forgot to put a switch on and that balloon has lifted up, there's no way. It is the same as going on an expedition and you forgot your antennas at home. You can switch off that equipment and go home. I mean, it means nothing. Or forgot your microphone at home. So yeah, this is very important. Final day test of launch. There you can see on the top left-hand side. I was busy testing the RTTY signal there to make sure we received it. On the right-hand side is also some preparations for Willie's car. It's also a chase car. And then I think I've mentioned it before. There must be at least 2 persons per chase car. One driver and the other operate the chase equipment. So one person cannot drive safely and chase. Okay, there at the bottom, it's one chase car. It's all the antennas connected to all the radios. And here's another chase car. You can't see all the antennas, but if you look, all the lines there on top, all antennas on the roof. Some chase cars don't have that much, and they also have a good record of finding the payload. During the day, when we launch the morning, depends on the wind direction and predictions. This is now my personally. I normally left when the balloon is start filling with hydrogen. I hit the road and I get someplace, get myself comfortable, me and the driver or whoever is coming along, and to have some coffee on the way, wait there and see which direction the balloon is moving. As I said, sometimes you have directions and the wind just changed that day and take the balloon to another direction. Then, yeah, there's other chasers. They normally leave the launch site when the balloon is lifting, and they drive with the balloon as the balloon travels as far as possible. Okay, and then the chase cars do their own tracking of the balloon. Sometimes you can see the balloon up to 23 kilometers up in the air with a naked eye. It was a couple of times I stood below the balloon, watching up, watch the balloon hanging at one place. seems to be the balloon is going up and down, but and a little bit in a circle, but not very much. It stays in one position. Once it does that, and you can have a look at it with the naked eye, you must be looking very carefully, because this is very close to the point where the balloon will burst. You're still looking at that balloon and suddenly it just disappears. You can't see it anymore. You flicker your eyes, you see maybe it's the light or whatever. But if you look at the data, that balloon has burst, and then things happens quite fast and quick. Then you must get back into the car and start chasing. The base station and chase cars, we share the info because the main purpose doesn't matter who. It's nice to be first on the payload where it landed, but the main purpose is to find the payload. So we all work together, give info to each other, so that we can find it fast and quick. When the payload's on the ground, it's still TXing info, but you have to be close to receive the signals, because it's nearly like the signals is very small. It's not great signal, so you have to be close, fairly close to receive the signals and decode it still, to take you straight at the GPS coordinates. Sometimes you find the payload near the road. Sometimes you have to walk quite a distance in the field to fetch it. As I said, sometimes you walk very far. And once you get to it, you'll find that I think at one stage, Krista and Willie, there was someone else with him. They found the payload in a tree. So yeah, they battled to get that payload out. Yeah, and I think one of the questions was been asked, also been answered. In most cases, you first have to report to the farmhouse or landowner, telling him or her who you are, what are you doing to get permission to access the ground. We are privileged to have a helicopter joining us on the last 2 years in our chasing team and assisting the team on the ground. There is a few challenges to sort, but it's a huge help to find the payloads and sometimes to airlift the payloads from difficult landing zones. I think Willie flew the last year with the pilot of the helicopter. So yeah, there's a few things. We need some APRS installed inside the helicopter, so that they can find the payload much more quicker. And then at one stage, the payload landed inside a mining area, and it was very difficult for us to get inside. The gates is closed, and when there's security, they first got the permission and they must get some people out. And then you're on the wrong road in any case at that stage because it's lying on the other side of the mine, etc. So at one point in time, the helicopter flew in, land, pick up the payload, fly out, and bring it to us to the road. So yeah, that was quite nice. Otherwise, we would have battled to find that payload or to retrieve it. There's a picture of one of the chase cars from Eastern branch with a helicopter. I think they're busy filling it again with fuel before the lady pilot flew back to Springs or Benoni, where she was stationed. Here you can see an example of a field base station. This is only a small part of it. This was our second flight. We couldn't get permission to start the flight from Klerksdorp at that stage. And this was in Vryburg. We have 2 payloads launched that day, and we lost both payloads. And luckily, after that, I think Crystal got it right to get permission to launch from Secunda, so we didn't have to travel that far. To travel that far is quite a mission. All the equipment had to go where you had to cater for everything. So yeah, it was quite a challenge. Here is core. Also, I think it was in the Vryburg area, trying to get signal, see if we can't find the payloads. Again, a chase vehicle. And this one, it's our first payload. We launched from Klerksdorp. That is the one I told you about, which changed direction, eventually comes hanging over Valdam for quite a while. The wind took it over Heidelberg to the Devon area. And I think it was 10 kilometers outside Devon. We find the payload. Around about 50, 70 meters from the road. It was hanging there in the fence of one of the farmers. So this was our first payload, so we was quite chuffed to put it back. Here on the top hand side, this was a misleading payload lying in the field. We was looking for our payload. This is the one where I told you where I went off without water, without a hat, everything I had to turn eventually back. This is what I saw in the field. I thought it was part of our payload. It was not. There's I think some weather balloon which just landed there, lying there in the field. We also pick it up, brought it back to the launch site. But yeah, if you're looking for payloads, you see things like that, you're wandering deeper and deeper into the field. Hopefully we found it quickly. The picture just next to it, this is the actual payload, which we found that specific day. I think this picture Willie also shown. This is where we did have a hard landing in the field. That was the one the parachute did not open. And it was quite stretched out in the millie field. It was also quite a long walk to find it. This was also Christo preparing. You had to know the weight of your payloads. It's very important. And then you do some calculations, how much gas you had to put into the balloon to do a proper liftoff. But you can't do too much because otherwise you burn the balloon pop at a very low height. Sorry, I just want to quickly go back to the previous slide. I'm skipping one. This was also one of the payloads retrieved. And the one on the left-hand side, this was last year's payload. I'm chasing now for 11 years balloons, BACAR balloons, and even not our own, even if other branches, like I think it was Sasselberg branch, which launched also balloons, I helped chasing. And this one last year was the first time I was there in the vicinity when it came down and landed. It was quite an experience to see it for the first time coming out of the air. Normally I missed it going behind me, looking another direction. But this time it was straight. I'll show you a quick video. just after the slide. And yeah, and this was also the one in the field where we find it. That was the one which landed very hard. And this was a team chasing last year's balloon. This lady standing here, this is a pilot of the helicopter. The helicopter was parked a bit more on the right-hand side. This was some close-up photos of that payload which falls straight from air without parachute. You can see it's quite a lot of damage, but luckily the SD cards did have the data. We could have loaded it onto other equipment and get the data. Now, if you just give me a moment, I'm not sure. Can you see the new slide? With the video, or must I
Not
move?
yet, Gert. I think it was
Okay.
put on the other, share the other screen.
I'll quickly do that. First, I have to take this one out of full screen. Um,
While Gert is changing the screens there, is there any questions?
Not so many questions, Christo, but some observations. I
Yes.
didn't of raincoats and lightning and anything like that. I was the safety elements haven't been thought about by myself anyway of the launch, and obviously on the tracking. So that is very interesting. And then also the tracking of the temperature and the battery. That was also very interesting. So all those parameters where you're actually tracking that, and that pickaxe board I found very, very interesting. I'll have to get one of those and see if we can play.
Yes. Okay, Gert got it. Go for it, Gert.
I just want to go full screen. The sound is, I'll put the sound down because there's a lot of noise finding it. But this was the video which was taken. You can see that dot there. This is a payload coming in to land. I'm not sure how to take this bottom part away, but
you are connected to the Stanton Amateur Radio.
okay, there you can see the parachute and part of the payload hanging there. But it's at this stage is coming straight to us. And at the later point, it was turning to the left-hand side. There you can see some land at the bottom. There's a dam, but it landed between us and the dam. Okay,
That was
now
lovely.
we was running now to the payload because we was very excited to have seen this land in front of us. There it was lying on the ground. And you will see some of the stuff is quite wrangled up, twisted up there. Okay, now I must get out of here. And share that screen. Okay. Lastly, but not least, I think Billy also touched on it. Once you've got everything back, it's to analyze your data. Everything you got. Temperatures, how the height, your climb meters, per minute, meters per hour, climbing, falling down with a parachute, all of that stuff been analyzed, and then you try to improve on your next flight. I think last time we've made the parachute a bit smaller, Krista, if I'm correct, at one stage, and I think it is quite optimized at this point in time, just by analyzing the data and going forward. And then just one last slide, picture at the bottom, you'll see the yellow lines. This was one of the actual flights. We was launching here. It was climbing in one direction. And then at a one stage, it crosses to crosswinds, which change direction in the opposite direction. And as it climbs, it goes through that part. And then the wind changes back again to closely to the original side. So the winds up there runs in different directions before it eventually burst here and coming down with a parachute, the wind take it and brought it down for us on this film. So I think this is what I've got. Thank you. And if there's any questions, please.
Thank you very much, Gert. I think there's a question from Kevin in the chat. Were the photos transmitted during the flight, or were they retrieved later on?
There was at one stage that some photos was being transmitted down via slow scan TV. That was a project for people on the ground, whoever wants. We told them that we will have some slow scan TV pictures, but most of them is been retrieved later on.
Okay, thank you for that.
Can I just elaborate a little bit on that? I think Guy and his team is currently the slow scan TV experts on balloon flights. I think for the past few years, they are trying different ways of transmitting slow scan TV from the balloon. And I think this year as well, they are going to have another payload with slow scan TV on it. And each time it gets better. You must remember that thing turns around and shakes a lot there while it is going up. So it's quite difficult. But yeah, most of it is getting retrieved from the memory cards. And the other thing is in terms of the wind direction, the wind that we experience on the ground, ground effect is not the winds that is driving the balloon. So for the first 200-300 meters, the wind turns basically 180 degrees. Thereafter, it goes, for instance, in a easterly direction until it reaches 10,000 meters. Then it goes straight west until it reaches 20,000 meters. Then it changes direction again and goes to the eastern side again. It is in the jet streams, and it travels, the balloon at one stage, I think, traveled at 186 kilometers an hour horizontally. So yeah, those winds up there is hectic. Therefore, we need to make sure everything stays together. Just some background.
Yeah, I just want to add, Krista, that specific one from Klerksdorp, which we find near Devon. I think we clocked 210 kilometers an hour at one stage on that balloon.
Jeepers. And with this rotating and shaking around and all the rest, it's just like a normal satellite, I suppose, if it's moving away from you. I don't know if you've got the or moving towards you. I'm not sure if you've got the what's the effect called in terms of radio signal, Doppler effect with your radio signals. And also if it's circularly polarized or left or right, I'm not sure if that has any effect, just like a normal satellite.
Krista, thank you.
The effect, we can see it on the slow scan that came down. You can see the lines as it loses. And the thing, it seems like it is turning around the whole time it's like rotating. So then you lose contact, and then you get contact again, and we could clearly see it on the slow scan TV. No, but the Doppler and that, I think we are too close for any effect that we could detect. But one interesting thing now that you talk about Doppler is that once there was a crossband repeater on it, and somebody in Pietermaritzburg spoke to somebody in Lichtenburg with 2 handheld radios, 5 watt up, 5 watt down. So it's about 850 kilometers with 2 handheld radios on FM, which is quite interesting. Just some interesting thing.
That is very interesting, Christo. Thank you. Let's see if there's any questions. Does anybody want to ask any questions whilst we've got the BACAR team on? And you heard Christo indicate that they're having to watch the weather patterns for the launch on the 14th. So any questions for the BACAR team, anybody? No more questions coming through at this particular time. Okay, I know we're way over time, but I thought it was very, very interesting, Christo. So thank you very much, Gert, Christo, and Willie for this presentation this evening. It is fascinating. We have made a recording of it. I hope you don't mind if we put that onto a YouTube link so that we've got this for posterity, and that anybody else who wants to follow through or listen to the presentation, it will be available to them. And I have been broadcasting it on Echolink as well. I don't think there's many people on Echolink at this time, but for those that are on Echolink, do you have any questions for the team?
Keith, Guy.
Please go ahead, Guy.
Yeah, just a request to everyone that's out there, you know, if you're not going to come and join the camping and the chasing and the launching and all the fun we're going to be having, and you do happen to tune in and receive some signals, we'd like to know about it, because it's quite interesting to see how far your SSTV going or how far the beacon is going. So spread the word if you don't mind, and let's see who comes back to us.
Thank you very much, Guy. Would we be able to then get a schedule of the different frequencies and what's transmitting so we can listen out for that?
We'll arrange that with
Yes,
Christo as
yes.
soon as we have the first meeting. Christo, is that correct?
Yeah, no, we will definitely, I will definitely compile that list, and then we will publish it either on the SRL website or somewhere in a bulletin or something. We will try to get it out as far as possible.
Excellent. I'm intending to be there because I want to go and have the fun that you guys have out there as well. But I think it would be very interesting to be able to listen in and chase. I see that Brandon says an awesome presentation, very inspiring. Stuart has said many thanks for a very, very interesting presentation. So good comments coming through to the BACAR team. Then I'd like to say a very big thank you to Guy, because he said, come on, Santon, why don't you get a payload on BACAR? And suddenly we've got 3 items going on BACAR from the Santon community. Stuart's got a whisper beacon going up there, running on HF. We've got Paul that's putting a plasma thruster on a payload, and we've got our normal Santon Fox running on UHF. That'll be one of the on the payload as well. So it'll be very, very interesting. I see Kevin says an awesome project as well. So I'd like to say a very big thank you to Christo, Gert, and Willie for coming on this evening and for sharing their knowledge and the skills that they've developed over time. And it is a lot more complicated than I actually even thought. So having to deal with the various aviation authorities, that I thought had to be done, but then the chase car and all the elements that you have to prepare for the chase car and the base station are very, very interesting indeed. Christo, then I'd like to just hand over to you to thank your team and to close the proceedings.
Yes, thank you, Keith. Yeah, I need to thank Gert and Willie for their presentations as well. I know Willie was today very, very busy. It's month end, so they got a lot of reporting to do. And Gert, also for your time that you spent on your presentation, it was excellent. I think it is very good introduction and training material that Gert compiled for anybody that is interested in chasing. And also for the opportunity to talk to you guys and share our passion. I think that is the most important thing. In our hobby, we need to do more of these things where we can share stuff with people that is interested, even if it's just 3 or 4. We need to grow it, and there is so much that we can do, and so many payloads that can be built. This thing will keep us busy for another 10 years with different payloads. There's high frequency stuff that we also need to look at. There is interesting enough is this year the University of Potchefstroom is interested in sending up a sensor to measure radiation in our balloon. That is I'm looking forward to that. And then and Paul was one of our victims in 2021. He didn't sleep for 2 days preparing his payload. But yeah, I'm very glad I'm speaking almost daily to him. He fixed up his warp drive quite well. I'm also looking forward to that. Interesting to see that fly as well. Yeah, but and Keith, thank you for you and the team for inviting us. Looking forward to meet you. Bring meat, bring red wine. If you are from locally here, you will bring brandewyn and Coke, but you're welcome to bring anything that you like. And yeah, if you want to camp, get in contact with Gert. We'll sort you out. We are now sorted out with all the water shedding as well. Power shedding, we don't worry about. If the sun goes down, we make a fire and be dry. So thank you very much, guys. It was a nice experience. Thanks a lot.
Thank you very much, Christo. Thank you, Willie. Thank you, Gert, for all the time and attention you put into this, and a fascinating presentation. I'd like to say a very big thank you to all who joined us this evening, and I hope that you did learn something and got something out of a BACAR. And I see Brandon is sold. Kevin says, thanks indeed. Amazing info and prezzo. And thank you to the team. That brings us to the end of the STN presentation or Tech Talk Power Hour this evening. The next one will be in a month's time on the last Thursday of the month. But before then, we hope to fly a BACAR. Thank you, everybody, and good night.
Good night.
Thank you. Good night.
Good ball, guys. Bye-bye.
Good night.
Cheers all. Good night.
Thanks, everybody. Have a good evening. 7-3.